So next up, I want to show you, from VR3, what they offer, what options we have to take, and the different services that they can do. So, in our specific case, we of course use them for all of the tubes. We also use them to make a lot of our suspension mounting, which has some rather precarious geometry associated with it as well. Same with suspension mounting, and then a couple other small pieces like our engine braces that also carry our shocks. It's important to know what their machines are capable of so that when we design something, whether it be simple like this or a bit more complicated, like one of our suspension mounts, there's ways you can design it that are going to make a cleaner finish on the actual product, and then also are going to end up, more accurate to what you want and aren't going to, quite bluntly piss them off. Another thing to consider is with the bends as well. There's minimum distances. So we'll start with these guys here because it's one of our most complex pieces we grab from them. Um, you need to know how the actual cutters there work. So a lot of people, when they think of tube notching, they think of the traditional sense, where you have some tool and you're spinning it and you're shoving it through and it's imparting right its profile onto it. So they do not use this type of tube notcher at all. And then what most people think of complex geometry tube notchers, they think of something like a laser cutter. Laser cutters can do much tighter corners. They can do a couple more types of sweeps, and they can also do like what's being shown here, where they're cutting off axis. Um, this is not the type of process VR3 uses. They actually use what was very similar to an end mill in place of where the laser is. So they can actually cut perpendicular to the part as well as cutting angles in it, and you get a bit of a different finish, and you don't have the heat that the laser would cause, which helps get a little bit more precision out of it. The big things to note in it is they have in their technical documents here 3D modeling guidelines. When you dive into it, they show a bit of what the profile differences look like. So this is the trim you're going to get in SolidWorks. And then on this side, they've they've shown what it's like being cut in their process. If you're ever curious, you can get to this result pretty easily if you take your outside line or your inside line, whichever one you prefer to use, and you turn it into a surface, and then you extrude that surface, perpendicular to that cut. You can end up with what they've modeled over here. So the big place to pay attention with this one is when you make your cuts here, think a little bit in 2D, right? Try and make it easy. You know that the mill can run across this while facing, up down in what's my y axis right now, and then they can rotate it and they can run it through again, with the z axis being up and down. So you can of course get more complex than this, but be thinking about what you need. What do you actually need for clearances there? What are you gaining by making it more complex? Is this something that could slow down the process that you're gonna have to speak to them about? Be conscious of a lot of things. Your goal is obviously to get this chassis as quickly as possible and something that functions in the way you intended. Um, keep it simple, man. Then the other big thing to go into is bends. Especially on the seatbelt hoop. This is actually a part that they cannot manufacture. They cannot put this cope in a bend. So what they're going to end up shipping us is a bent tube with 2 straight ends attached to it. And when you get into bends, you have a couple things you need to include. First off, you need to read their documentation and know what radii bends they're capable of producing. So we're using 1-inch tube here. Our rules require us to have 3 times the diameter for our minimum bend radius. So the minimum bend radius we could run here would be 3 inches. VR3 has a die for 3 inches. It's probably not the wisest idea to do a 3-inch die on a bend that by rules has a minimum of 3 inches, right? Look at the comparison between a 3-inch bend or a 3 1/4, which is what we're currently running. So 3 1/4 is obviously the next size up that VR3 is able to offer. So when looking at bends, you need not only look at the radii, right, and the diameter, you also have to look at how much space is left in between bends. This is the zone they're going to grip with the bender. And if they don't have enough material here to grip, then they cannot make these multiple bends. So they have a really good example of that in their modeling guideline as well, where they show you an example bent tube and the amount of distance between the different radii that you're able to have. And they go into what minimums they can have per the different ones in this chart. So I mean, for 1 inch, 3.5 inches minimum. If you're over this wall thickness, as you get down in wall thickness, you need more straight tube between that, which makes perfect sense. Tubes like to buckle. It's a good chart to go by. Another thing to remember in these is out of plane bends are gonna add in a lot more error. So these 3 bends that comprise the top of this hoop, not terrible. When they get down there and they have to make this bend and it's out of plane of the other 3 here, that's gonna be a spot where a lot of error can get introduced. The VR3 tends to nail it to 1/10 of a degree. They tend to be really, really spot on. But that is something you want to keep in mind when jigging and constraining these parts. Then of course, like your front bend, all these are in plane. But even in our front hoop, we do get pretty small in here between bends. So you gotta spend when you're designing, going through everything, make sure you're keeping it above that minimum number so that it's something you can get. And then for things like the seatbelt bar, you just need to understand that it's going to come with some straights, and we're going to have to put it in and notch the ends of it ourselves. Luckily for the seatbelt bar, it's the simplest notch you're going to have on the car. Let's see what else we got for this. So common issues we run into have been the bends. The roll hoops are always a little bit out of spec. It's the nature of the beast with something being a bent tube. We get them hand bent. You need to pay attention to documentation. There's things the CNC bender can do, and there's things that the hand bender can do. You want to stay in the hand bender. The way we do these suspension nodes, we've changed it up a little bit throughout the years. We found this one to be pretty agreeable, both for welding in the spaces we weld in and working with it on our end, and also, the ability for them to make it quite easily and not a lot of argument comes about as far as, how the edges are going to come out. So that's probably the biggest bit there. And then I want to touch a bit on things like hollow nodes, purely because we ran one this year. And they talk about them quite a bit. So when you're going in, you're designing these notched edges. Most bends, like we'll take this one up here for example. This is our thickest tube, so it's going to be continuous. It's also a roll hoop. This is our second most critical tube. So as you can see, it goes all the way through and it lands being notched only by the red tube. Then our third most critical tube runs in here and it rests against our most critical tube and our second most critical tube. That is not a hollow node, and it's not a hollow node because this tube goes all the way through it and welds in first. An example of a hollow node is this guy in the corner. If you can see both these tubes, they stop at this joint with each other. The reason it was done in this case is when we fit these in, it's much easier to fit them both in at once and meet them together and weld them. They're also not an incredibly high strength, area. This isn't somewhere where we needed that stiffness. These two tubes, their primary purpose is to counteract the forces of the bell crank. So not something we're, super concerned with. We're not going to end up with a weird shear in here. They are very kind and they will notice these types of things and call it out. And it's up to you to address it or keep it as is. In a lot of cases, it does make assembly more difficult because you're lining up two things at once rather than notching one tube in at a time. all things to keep in mind.